far beyond the warm glow of our sun, past the rocky worlds we know, and beyond the swirling storms of Jupiter and Saturn, there lies a planet so distant, so cold, and so mysterious that for centuries it existed only in our imagination. This is Neptune, the eighth planet from the Sun, and one of the most enigmatic worlds in our solar system. Today, we journey to the far reaches of our cosmic neighborhood, a world of sapphire clouds, supersonic winds, hidden oceans, and a moon unlike any other. This is the story of Neptune. Neptune is the only planet in our solar system discovered not by sight, but by mathematics. In the early 1800s, astronomers noticed that Uranus was drifting slightly in its orbit, as if being pulled by an invisible force. Two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, predicted that another planet must exist even farther from the Sun. On September 23, 1846, astronomer Johann Galle pointed his telescope toward the coordinates Le Verrier had calculated. There it was, a faint blue disk, a planet found by pure human reasoning before anyone had ever seen it. It was named Neptune, after the Roman god of the sea. Neptune lies about 4.5 billion kilometers or 2.8 billion miles from the Sun. Sunlight takes more than 4 hours to reach it. Daylight on Neptune is as dim as a cloudy winter evening on Earth. Its deep blue color comes partly from methane gas, which absorbs red light and reflects blue light. Deeper clouds and aerosols also shape its unique appearance. Neptune's diameter is almost 4 times that of Earth, about 49,500 kilometers or 30,760 miles. But despite being larger than Uranus, Neptune is actually slightly smaller in size while being more massive. This makes Neptune the densest of the ice giants. Neptune is extremely active. It has the fastest winds in the entire solar system, reaching speeds up to 2,100 kilometers per hour or 1,300 miles per hour, faster than the speed of sound. Imagine storms so powerful they could encircle the planet in a matter of hours. In 1989, NASA's Voyager 2 spacecraft photographed a massive storm called the Great Dark Spot. It was roughly the size of Earth. A few years later, it vanished completely. On Neptune, storms don't last centuries. They rise, rage, and fade into the blue atmosphere. One of Neptune's strangest mysteries is its internal heat. It emits more than twice as much energy as it receives from the Sun. Scientists believe this heat may be leftover energy from the planet's formation, or from heavy materials slowly sinking deeper toward the core. Beneath Neptune's upper atmosphere, temperatures and pressures rise dramatically. Water, methane, and ammonia may form exotic ices, not cold, solid ice like on Earth, but hot, slushy materials under extreme pressure. Some scientists think Neptune might contain a vast supercritical ocean, a bizarre state between liquid and gas. Even deeper, pressures may be so intense that carbon atoms crystallize into diamonds. Neptune may literally experience diamond rain. Neptune also has a faint ring system, thin, dark, and uneven. These rings were first suspected in the 1980s, when stars passing behind Neptune briefly dimmed. Voyager 2 later confirmed the rings and revealed that they contain bright arcs, clumps of material that should naturally spread out over time. They remain intact, likely held together by small nearby moons called shepherd moons. Orbiting Neptune is Triton, one of the most unusual moons in the solar system. Triton moves in a retrograde orbit. It travels backward, opposite Neptune's rotation. This indicates that Triton was not born around Neptune. It was captured. Billions of years ago, Triton may have been a dwarf planet in the Kuiper belt, similar to Pluto. Neptune's gravity pulled Triton in, and this violent capture likely destroyed other moons that once orbited Neptune. Despite its extremely low temperature of around -235 degrees Celsius or -391 degrees Fahrenheit, Triton is active. Voyager 2 observed geysers of nitrogen gas erupting up to 8 kilometers high, or about 5 miles. These eruptions left long, dark streaks across Triton's icy surface. Beneath the frozen crust, scientists believe Triton may hide a subsurface ocean. But Triton is spiraling gradually inward. One day, far in the future, it will come so close to Neptune that it will be torn apart by tidal forces. The debris may form a spectacular ring system, a final transformation from moon to rings. A day on Neptune lasts only 16 hours, but a year is incredibly long, 165 Earth years. No human has ever lived through a full Neptunian year. In 2011, Neptune completed its first full orbit since it was discovered in 1846. Only one spacecraft has ever visited Neptune, Voyager 2, in 1989. Its flyby lasted just a few hours, but it fundamentally changed our understanding of the outer solar system. Since then, Neptune has remained unexplored. No orbiters, no landers, only distant telescope observations. Future missions, including NASA's Trident concept and studies for a dedicated Neptune orbiter, may one day explore this distant world. Understanding Neptune is important not only for our solar system, but because ice giant planets appear to be among the most common types of planets in the galaxy. Neptune is a world of extremes: violent winds, freezing temperatures, mysterious heat, hidden oceans, diamond rain, faint rings, and a captured moon. It reminds us how vast our solar system truly is and how many mysteries remain. As humanity looks farther outward toward new missions and new horizons, Neptune stands as a distant beacon of wonder, a blue giant guarding the frontier of our celestial neighborhood. The planet's outer atmosphere continues to reveal new wonders through modern observations. Using infrared and ultraviolet telescopes, astronomers have detected shifting temperature bands and changing cloud layers that evolve over the course of Neptune's long seasons. Seasons that last more than 40 Earth years each. Bright methane clouds appear, stretch across the sky, and then dissolve into the atmosphere, leaving behind questions about the processes occurring deep within the planet's unseen layers. Unlike Earth's magnetic field, which is roughly centered and aligned with our rotation, Neptune's is wildly offset, shifted far from the core and tilted dramatically. This creates a magnetic environment that wobbles and pulses in unpredictable patterns as the planet spins. Such behavior offers scientists a rare opportunity to study magnetic fields that operate under entirely different physical rules. Neptune's influence also reaches outward, shaping the structure of the distant Kuiper belt. Many icy worlds beyond Neptune follow orbital rhythms dictated by the giant's gravity. These resonances preserve their orbits over billions of years, acting like cosmic choreography set into motion when the solar system was young. By studying these distant objects and their relationships with Neptune, scientists gain insight into how planets migrated and settled into their current positions. As our exploration comes to a close, we leave Neptune drifting in the silent dark at the edge of the solar system. Its winds sculpting the clouds, its magnetic field twisting through space, its deep interior shining with heat that refuses to fade. Neptune stands as a symbol of curiosity, a world so distant, yet so deeply connected to our understanding of the cosmos. If journeys like this leave you curious for more, letting me know truly helps. It helps me chart the course for the episodes still to come. Thanks for exploring with me. The universe has many more stories to tell.